Welcome back, glorious Godot people. In this video, we're going to start using the engine and get to grips with it by making Godot say hello world. This is traditional, right? Every time you start a new programming language, the first thing you try and do is you make it say hello world. So we're going to say hello to Godot. To do that, we're going to have to figure out how to start a new project and how to make it say hello world. Nice and simple. So here's my desktop, and I'm going to open Godot 3.1. You'll notice I'm currently using beta release 2, or beta release 2, depending on your accent. That's because at the time of recording, Godot 3.1 isn't officially released yet, but I'm not expecting any major changes, and if there are, I can re-record the video. So, I'm going to double click on it. I'm going to get this error message. You don't currently have any projects. Would you like to explore the official example projects in the asset library? I wouldn't, so I'm going to press cancel. Now, the reason why I've got a blank screen is I downloaded this directly from the Godot website, right? If you don't have this blank screen, if you have a bunch of projects in this area, there are two possible reasons. One, you've used Godot before, in which case you're probably not surprised that you see things here. The other is you downloaded it from Steam, because Steam will give you a bunch of example templates, and you can see a lot of them here. When I look at the templates, I can see tutorials, examples, projects you can build on, and some of them are very cool. However, I'm not going to do that. I'm going to make a new project. Also, if English is not your first language, pick your language. I'm going to stick with English because it's my preferred language. It's the one I'm best at. And I'm going to click New Project. Okay, now you'll probably see that some of the stuff in the background has changed. That's because I've gone and re-recorded this. Hello, this is Jan from the future. The reason is the screen for a new project has actually changed since I recorded this, because I recorded it originally in beta. We're now live. So I press a new project and I'm going to get this window. So first thing I'm going to do is I'm going to type hello Godot. That's the name of my new project. And you'll see here, it's not going to let me create anything. And it's got a project file. I'm going to document.repos. I'll show you how to change your default project file. And if I want this to work, I need an empty folder. So what I'm going to do is create folder. And you'll see this now goes green. We've created the right folder. What render do we want? You can read the descriptions here. In this particular case, it doesn't really matter. If you're using an older machine or a smaller machine, or you want to do something on the web, use OpenGL ES2. I'm going to be doing OpenGL ES3. So I'm going to create my project. And here it is. And I'll now leave you in the capable hands of me from the past. All right, so if you've used a previous version of Godot, you'll notice that the layout is slightly different. Not massively, but slightly. If you haven't, this is all new to you. So I'm just going to switch to this snapshot mode that Windows 10 has, snip and sketch it's called, which is a strange phrase. And I'm just going to highlight these various areas. So over here, we have a scene tree. Over here, we have the file system. And this over here is the inspector. Okay, the scene tree is where we're going to develop all of the nodes in our scenes. And we're going to explore what that means in a few videos. The key concept here is the node is like a building block, right? Each node can do a specific thing. So a node might be a sprite. It might be an animation player. It might be an audio player. It might be a timer. So if I need a timer in my game, I'll put a timer node into the scene. Scene is a little bit more abstract. For now, we could just take the more literal idea of a scene. You can imagine a scene as a single room, a single place. Actually, the way that Godot handles scenes is a lot more clever than that. Almost anything can be a scene, but we'll explore that when it becomes necessary. The file system is all the files that are in this project. You see here, we've got res. Res stands for resource. This is the folder that we've created for this project. Okay, so in this case, it's hello Godot. And before we go any further, if you want to change the layout, all you need to do is click these three dots and change your dock position. So I'm going to put this here, I'm going to put this here, and it's all changed. Right? I'm going to put my import tab over there. If I don't like it, I can go to Editor, Editor Layout, and hit Default, and it'll put it back. Now, I did say that there is a way you can change where your default repository folder is. To go to that, go to Editor Settings, and all of these are settings that'll change every time you run the engine. Okay, these are not bound by project. So I can go to Directories, and here is my default project path. I've got it to D, which is my hard drive, Documents, Repos. While we're here, you could also go to Theme and change the colors. So we have a bunch of presets. I'm going to be using default, but you could use Alien, which is nice and dark with green highlights. Very spooky. Maybe you want a light theme. Here's a nice light theme. Or you can create your own one. The base color is going to be this lovely purpley color. There we go. and the accent color is going to be bright red. That is completely unusable. So I'm just going to reset my theme and put it back to default. Great. I would recommend you keep the default theme just because it's going to be easier to follow along if my screen looks like yours. However, if you want to change it, change it. It's your Godot. You should do whatever you want with it. Okay, that was our quick whistle-stop tour. Let's take a look over here in the scene tree. The way that Godot works is that every scene is built up of nodes, and there is always a root node. And a root node can have a bunch of child nodes. Godot is going to ask us to make a decision of what our root node is. If we want a 2D scene, we should pick this one, a 3D scene. Is this user interface, or do you want something else? And if I press custom node, here is a list of all the nodes in Godot. And we can expand these, so the node 2D has all of these, and joint 2Ds have all of these, and we can keep going. We don't need to worry too much about what these all are, but what is interesting is the way that they inherit. Every node automatically has access to all of the properties that its parent node have. For example, node 2D is a 2D game object, the parent of all 2D related nodes. It has position, rotation, scale, and z-index. What that means is if I click on any one of these, let's say a light 2D, it will have access to the position, scale, rotation, and z-index. Node 2D has access to all of the node properties, and this is the simplest thing we can have, right? This is the base class. So what I'm going to do is I'm going to create a basic node. And over here I can see the properties of a node, and it has access to pause, which we're not going to worry about for a few games, and it can hold a script. That's all a basic node can do. What if I don't want this? I'm going to close this scene, don't save it, and make a new one. If I make a classic 2D scene, it has all the properties of node, and it has all the properties of canvas items, and it has its own properties. Okay, so anything that can be accessed by canvas item, for example, visibility, can be accessed by node 2D and all of node 2D's children. All right, so let's get rid of the scene, and I'm going to make a brand new node, and I'm going to call this Hello World. The convention here is that nodes should have a capital letter for each word, but no spaces. Okay, this is just the guidelines within the style document. Okay, so right now I want Hello World, and if I click on Output, here I'm just going to clear it. This is where any error messages or printouts are going to happen. This isn't what the player sees, this is what we can see. So we can use a print command to print things out at various points in the code. This is a really useful tool when we're debugging, we're trying to find errors, or just trying to make sure that something is working as we expect. So let's click on Hello World and click on this Attach New or Existing Script button. So it's a little scroll with a green plus on it. We'll click that. And here we have our script thing. We can change language. I'm not currently using the mono build. That's the C# build of Godot. So I don't have C# in here. I'm not going to use native script. I'm not going to use Visual Script, which is the visual scripting language, mostly because I don't personally find it that useful. But if you want to, that's how you'd access it. I'm going to use GD script. It inherits node. This is a basic node. And we don't need a template for it, so I'm going to leave it as default. I could also have an empty template and no comments. We'll look at that later. Everything else I'm just going to save as is and press create, and here is our script, which is in the script tab. Okay, if we look down at the file system, our new script has just appeared, helloworld.gd. If we look at Hello World, it now has a script icon. We can click that to get to the script, and within the script tab, we can see all the scripts we have opened. We can also press this little button here. This is distraction-free mode. If I press this, we get rid of the other things we don't need. I can't see the inspector, I can't see the scene tree, I can't see the file system. I can just see the script. And let's take a very quick look at what we've got here. The first line is important. Extends, and then a node type. Extends node. That means this script is supposed to work on a node, as in the type of node called node. If I typed node 2D, it could only work on a node 2D. It will not work on this because this is not a node 2D. This is a node. So I'm going to put it back to node. Extends is a keyword. Keywords are in red. What does extends mean? It means take all the basic functionality that's inside a node, which is pause and script, and extend the following behavior. Anything with this little symbol here, which in England is called hash, in America is called pound, and I don't know what it's called in other countries, is a comment. Godot is going to ignore everything on this line after the hash sign. So declare member variables here, examples variable a equals 2, variable b equals text. Godot isn't going to look at that. If, on the other hand, I get rid of it, it changes color. That means Godot is reading it. I don't want these comments, so I'm going to delete them. And instead, we're left with a single code block. A single code block being a single chunk of code that does a thing. Code blocks in Godot are declared in functions. That's what this func keyword is, right? So every function has to have its own function code block. And underscore ready is a built-in function. What it does is it runs this script the moment the node has been created in game. Okay, so once the node has been created in the scene tree, you've put it in, now run this script. There are other things we can do to run it before you finish creating this node. The moment you enter the scene, run this script. Don't worry if you've created the node yet. We're not going to worry about that yet. Functions in Godot have to have these brackets here, and that's because some of them have an argument that comes in. So I might bring in a variable called name or player. This one doesn't need that, so I'm not going to put it in. Finally, let's take a look at what this function is doing. Function ready pass. What does pass do? It says, don't do this function, ignore this function. So what we have here is a script that does nothing. And if I press play, first it'll say, you've never saved it. Do you want to save it? And I'll say yes. Save it as hello world. And here's my Godot game, and nothing is happening, which actually is fantastic because that's what I told it to do. I told it to do nothing. But nothing isn't a very useful test. We want it to say hello world. And to do that, I'm going to replace pass with print. Print is a function. So it's going to take these brackets. Now, if I hold Control and click on print, the documentation is going to come up for that argument. Print ... And the dots are vararg. Vararg is not Orcish, it's variable arguments. It means you can put as many arguments as you want to in here. And I'm going to close this. I could right click on it and do close, or I could use this shortcut. On Windows there's Control W, so I'm just going to close that. You see this little star here? That means this script hasn't been saved. The moment I press play, well, this is the second time I've pressed play, so it says you haven't selected a main scene. So I'm just going to press select, do my hello world scene. There it is. Okay, nothing has printed here. What if I want something to print? Well, I'm going to put a string in here. A string is a series of letters and numbers and spaces. And anything within these quotes, it doesn't matter what I write, Godot isn't going to interpret them, it's just going to treat them as a variable. So I could say, hello world. And now when I press play, hello world is printed in the output. Now you'll notice it's not displayed in game, right? This is the game section. It's not showing the player anything because that's not what print does. Print puts things in the output. Okay, I mentioned the word variables, and to some of you this is a pretty simple topic. To some of you this is new information. So let's take a moment and all get on the same page. Variables, like functions, are a key concept in programming. They actually come from algebra. And Ben once described variables to me as an empty box. So here is our variable. And this empty box can have anything in it. Now, Godot doesn't really care what's inside the box. Godot cares about the variable, which means we can change what's inside when we need to. That's why it's a variable and not a constant. A constant is like a variable. It's called const, but we're not allowed to change it once the program starts running. Okay, so we're allowed to change it between runs, but at runtime, when the game is running, we're not allowed to go in here. A variable, on the other hand, this contents can change at runtime. So we can change it during gameplay. When I press a button, maybe the speed will change, something like that. And a variable is going to have a name, so I'm going to call this word. And we could put anything in here. And there are basic types of variables. There's a string. In fact, you know what? I'm going to change the color for this. Let's go with a nice, ooh, what do we have? A nice deep red. A string variable. We could also have an integer, a float, a Boolean. And there's a couple of others we can have as well. Colors, for example. These are the most common ones. Let's define what these are. A string is if you imagine one of those celebratory flag strings, right? So we have a string and a bunch of letters on them, and each of these characters fits on that string. So this string is a collection of numbers, letters, punctuation, and spaces. For the most part, Godot doesn't care what's inside the string. There are ways you can make it care, and we're going to do that in a little bit. An integer is a whole number. 5 is an integer. A float is a number with a decimal point. 5.25 is a float, not an integer. Boolean is a true or false value, which is incredibly useful in programming. Essentially, a variable is something we can change. It's a box. Here is a box called Word. Take a look at what's inside. Now, if you're used to a static programming language, something like C#, C++, any of the C-based languages, in fact, then you're used to the idea that variables have to be defined by type. These are called typed languages, right? So I have to say this variable is a string called this. By default, Godot doesn't do this. New in 3.1, it can. Let me define that. Godot, or GDScript, to be more accurate, GDScript is a dynamic language. Dynamic language, also known as duck typing. If it looks like a duck, and it walks like a duck, and it sounds like a duck, it's a duck. That's what duck typing means. In other words, this word variable could be anything we like. It could be a string, an integer, a float, or a boolean. If I say there is a variable called word, and I tell you it's 5, Godot will say, fine, that's an integer. If I say it's 5.25, it'll say, okay, it's not an integer, now it's a float. If I put it in a string, it'll say, okay, now it's a string. Dynamic languages don't care what type of variable you are. A typed language will say, well, you told me that this is a string, that's fine, but if I get rid of the quotation marks, it'll just say, nope, that's not a string, that's a float, you can't have this. There are advantages to using typed languages. I personally prefer dynamic typing, but it can slow the program down. New in 3.1, we can now have typed GDScript that allows us to define the types of variables in our script. So we can use the advantages of typed, but not go into C#. For the moment, I'm going to stick with dynamic because it's a lot easier to learn. Personally, I prefer it, but there are very good arguments why not. So we'll look at those a little later. So with all that said, let's put a variable in. I'm going to put my variable here. I'm going to use the variable keyword, var. And now it says, well, you've told me there's a var, but you haven't told me anything. Okay, so let's say word. In fact, you know what? I'm not saying a word. I'm going to say greeting. So now I have a variable called greeting. I'm not using it. To define it, I'm going to use equals. And it's going to be equals string hello. Okay, so how would I use that? Well, what I'm going to do is I'm going to get rid of everything in print. And I'm just going to say print the greeting. Nope, that's not the word. Greeting. There we go. When I press play, it's now printing greeting. And greeting isn't in quotes. It's looking for a variable called greeting, which it's learned here is hello. If I want it to say hello world, but I don't want to specify the word hello, I want to use a variable, I'm going to do this. Plus world. I'm adding a string that isn't a variable. You notice I put a space here. That's because this string doesn't have a space. I could also do that and it would work just fine. So now when I press play, hello world. Nice. So what we have here are operators. We have an equal and a plus. Equals is interesting. Equals sets a value. It doesn't check a value. Now, in common mathematics, equals means is the same as, right? So if I say greeting is the same as hello, that's fine. But what if I want to say check if the greeting is the same as hello? Well, if I put a single equal, I'm going to set greeting to hello. If I want to check a value, I need equals equals. Double equals is check, and right now it's saying you can't do that. You can't tell me there's a variable and tell me is it the same as this. Double equals is check, single equals is set. This plus here will concatenate these two things together because they are strings. You can't add strings like you can numbers. So I could do 5 plus 2 and print that, and it'll print 7. But if I do 5 as a string plus 2, It won't let me. Why? Because you can't add a number to a word. If I want 5 and then put a word in here, let me show how to do that. In fact, let's define a variable called number, and I'm going to call this 2, right? This is an integer called number. So I'm going to say 5 plus number. Try and do this, won't work. Why? Because I don't know how to add a word and a number. What I can do is turn this into a number. I'm going to cast it to be a string. str means cast as string. And now when I press play, the number is 52. Okay? So we can tell Godot, take this variable and translate it into another thing. So I can turn an integer into a float into a string, and so on. Which brings me to the challenge for this video. I would like you to change the code. We're going to print out the words, what are we waiting for, Godot, in the console, and I'd like you to use at least one variable. You could use more than one, but try and use at least one. So when you see this slide, remember this is a challenge. So pause the video, and when you come back, I'll show you my solution. Welcome back. Okay, so let's get rid of these completely and this completely. So the first thing I'm going to do is define my variable here. So I'm going to say people, and that's going to be a string called we with a space at the end. And I'm going to call this engine. Actually, I'm not. I'm going to call this thing, and this is going to be called Godot. And I'm going to type in a string. What are space? I'm going to close this string. I'm going to add in people and add in a new string. Then I'm just going to add my thing variable. And I'm going to put a space between the operator and the string, or the operator and the variable, because it makes it easier to read. Legibility in code is key. Godot will understand, Godot will understand this, but I as a reader might find that difficult. One of the most important skills we can develop when coding is making code that's easy for people to read. When you come back to your code in 6 months, or if someone else picks up your code, they should be able to look at it and follow what it does. So now if I press play, what are we waiting for? Godot! Look at that, we've done it. And that brings us to the end of the video. In this video, we've covered a lot of key concepts. How to start a project, where things are in the editor, how to start a script, how to print to the console, basic introduction to variables, and we'll go into a lot more depth here, and how to set your preferences. Don't worry if a lot of this is flown past. As we get used to the engine in the next few videos, this is going to become second nature. The first time you come up against the concept of variables, it can be quite confusing. But I think we're off to an excellent start. I think we're now ready to start our first real game, which is going to be Looney Lips, a word game. So, excellent work, and I'll see you in the next section.